Well, hello everybody. This is Mr. Dees. We are going over the Chapter 2 test review today for Algebra 1. So please have a copy of it ready. You can follow along and hopefully maybe pause the video here and there and then try the problem yourself and then see how I did it. And I think working together we'll be able to really review very well for this Chapter 2 exam. Here we go. It says draw a graph for the inequality. Well, before we can draw any graphs, we need to isolate the variable, which is something you did a lot last chapter. So let's go ahead and get the x by itself. I'm going to add 3 on both sides. Oh, pardon me, I'm sorry. Not going to do that. I'm going to subtract x from both sides. And the reason I'm doing that is because x minus x is 0, so it's gone. I'm left with a negative 3 over here, and now 2x minus x is 1x. So what does that say? Well, you know, I don't mean to be condescending here. This is the way that I remember being taught it back when I was in 7th grade, about 100 years ago. Is it says x is greater than negative 3. And the reason I can remember that the way you read this sign is greater than is because we kind of pretend this is like an alligator and it wants to eat more. Alligators are obviously critters that are hungry, so they're going to eat the bigger ones. So as I read from left to right, x would be bigger than negative 3, x is greater than negative 3. So as for graphing it now, I don't know what your teachers will require, but I only really require the important numbers, which would be only negative 3. I'm going to be shaded to the right because to the right of negative 3 is greater than. This is greater than, this is less than. But now we have an interesting dilemma here. Certainly we're going to put a circle there, but the question is, do I fill it in or not? And the answer is not. When the sign is greater than or less than, you use an open circle. But when it's greater than or equal to, less than or equal to, we use a closed circle. This is an open circle. And so there's our answer for number 1. On number 2, it actually asks us to write the inequality given the picture. And what you'll notice is that the numbers got kind of messed up a little bit. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So, you know, we'll just understand that's the way it is. So I'm going to put x here. My key number right here is negative 3. Now, am I shaded to the left or the right of negative 3 right there? I'm shaded to the left of it, which means x is less than negative 3. Is it less than or equal to? No, it's not. We look up here. If it's an open circle, it's one of these two signs, and so I just leave it like that. Check. Okay. So right here, it's x and negative 3 again is our key number. We are shaded to the left, so x is less than, but now it's a solid circle, closed circle, less than or equal to. Finally, on the last one here, x and negative 3 is my key number right there. It's shaded to the right, so x is greater than negative 3. And it's an open circle, which means it is strictly greater than, not greater than or equal to. Check, check. Love it. Hey, if this was a test, I'd be at 100% so far. Imagine that. Okay, so let's go on to number 3 and 4 here. Looks like I might need to darken it a little bit. Give me 1 sec here. Okay, maybe that's a little bit better. I hope the other ones were still visible. Solve each inequality and graph the solutions. So now it's a combination of the two. So let's get the variable by itself and then graph it. So to get the variable p by itself, I would divide by a negative 3 like we did last chapter. Negative 3 divided by negative 3 is 1. They cancel. 8 divided by negative 3 is, well, just leave it. 8 over negative 3. But, as some of you know, there's a little tricksy thing about this chapter, and when you divide or multiply by a negative coefficient, the inequality switches directions. I trust that your teacher explained why that's the case. But now, after having understood why it's the case, we can just go ahead and do it and not really fuss about it. So, my only critical number is negative 8/3. It's an open circle, because I don't have the line underneath, and it says that P is greater than that, so I shade to the right, because to the right is greater than. Pretty cool. We don't have to worry, at least if I was the teacher grading it, I wouldn't need all this 0, 1, 2, all that stuff. Talk to your teacher. Let's go ahead and isolate A here. I'm going to add 10 to both sides. So I get 7A is greater than or equal to 21. Now you'll notice I'm dividing by 7, but it's not negative. So I do not reverse the sign. And I get A is greater than or equal to 3. Now graphing it, 3 is their critical number. It's greater than or equal to, so I use the solid dot, and greater than is shaded to the right. Okay? And there you go. Good. Look at that. 1, 2, it's like I'm 5 out of 5 so far. Boom. Still got a couple more that are very similar here. Let's go ahead and isolate P. I am going to subtract 9P from both sides. So now it's 10 and is less than 4P minus 9P is negative 5P. Now to further isolate P, I divide by a negative 5 on both sides, and I get P is still on the right. I divide it by a negative, so that switches directions, and 10 divided by negative 5 is negative 2. Now if this looks odd, I'm with you. We usually don't write it like that, so I'm just you can leave it like this, or you can literally just reverse everything so that the P is there. See how the inequality is pointing at P, so it's going to point at P, and it's swallowing up negative 2. It's going to swallow up negative 2. So negative 2 is our key number. It's an open circle because there's no line underneath, and P is less than, so shade to the left. Okay, and now this one here looks like we got a pretty good clip of algebra to do before we can get to a place where we can graph it. So I'm going to combine these like terms first, and 7A plus 4A would be 11A minus 1 is greater than or equal to 8 plus 2A. Now I'm going to subtract 2A from both sides, and that's gone. And I'm going to add 1 to both sides, and that's gone. I don't know if your teachers, some of your teachers probably take one step to do this, some take 2. I'm kind of doing it all in one line. I just like to save space. What can I say? 11A minus 2A is 9A, and 8 plus 1 is 9. Continuing to get A by itself by dividing by 9 on both sides, I get A is greater than or equal to 1. 9 divided by 9 is 1. Why did I not reverse this symbol? Hey, good job. That's right, I heard you, because we didn't divide by negative. So A is greater than or equal to 1. Greater than or equal to is solid, and greater than or equal to is to the right. Okay? Good. Now number 7 is one of the most dreaded questions. I actually hate these. Because basically, what we need to do is choose which out of all of these would be graphed like this. So essentially what I have to do is get x by itself on all 8 of these and see which one says this. So first the question is, what does it say? Well, I'm shading to the left, so it's less than. And again, the numbers got fudged a little bit here. Boom, 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 bap, boom, boom, bap, right there. That's 3. X is less than 3, less than or equal to, right? It's solid. Okay, so now what? What's the logic of the question? Well, now what I need to do is get x by itself on every single one of these and see which of them say that. Yuck. Yeah, right. Let's do a couple of these the easy way here. Let's do this one first, B. If I subtract 8 over, it'll say x is less than or equal to 11 minus 8 is 3. So yep, that's what that says. Any other easy ones? This one's pretty easy right here. How would I get x by itself? I'd multiply by 3 on both sides. If I multiply by 3 here, they cancel. If I multiply by 3 here, that's 3 over there. Yep. Can you believe this, right? Yikes. So here, let's see if you guys are... I'm going to do one the way I would treat my students that are a little bit more advanced, and see if you like it. This is greater than or equal to. If I subtracted 4 over, how much would I have here now? 6. And then if I divide it by 2, how much would be over there? 3. And then x would be by itself. And while this one looks super duper close to this, it's not that, is it? This is greater than, that's less than, so it's got to go. Let me do part C down here since I'm running out of room. First I would subtract 2, and I get negative 5x is less than or equal to 15. Now some of you might be so good at this, you're looking at it going, Dees, it ain't gonna work. Sorry, my name's Mr. Dees. This is not gonna work. Well, why would they know that already? Because they can see when I divide by a negative, this is going to switch directions and be a greater than, but we see from up top that it has to be less than. So this doesn't work. C is out. But for those that just don't believe me, I'm going to divide by a negative 5 on both sides, and I get greater than or equal to, and right here is negative 5. So C, or negative 3, excuse me. So even though it's the negative, it's a 3, it's negative, that's cool. But no, the sign is in the wrong direction. Let's go do D. Okay? So this is negative 2x. If I add 7 over, right? Add 7. Negative 1 plus 7 is how much? 6. Now it looks like the sign's in the wrong direction. In fact, it is. But you guys see it, don't you? When you divide by the negative 2, it switches directions and we get negative 3. Now that looks pretty darn good, but it's not. Because it says x is less than or equal to negative 3. But it needs to be x is less than or equal to positive 3. So that one was close. Oh boy, these are tricky. On E, let me write it down. 1/2 x minus 3 is greater than or equal to 3. What would be the first step in getting x by itself? You got it. Add 3 to both sides. So I have 1/2 x, and over here 6. Now to get x by itself, I would multiply by 2 on both sides from last chapter. Don't reverse anything, and we get 12. Wrong number, wrong sign, E is out. So I think I've explained enough to, I'm not going to do every single one of these the way that you need to. I think I've explained how to do it. So I'm just going to do this in my head. Subtract over the 1 and we would get negative 12. Divide by the negative 4. This would reverse signs because I divided by negative. And really that's x is less than or equal to 3. So that's a keeper. This one here I'd add 2 over, so that's 9. I divide by 3, so that's 3, and x is left by itself. Boom. So B, F, G, and H are equal, or excuse me, are properly graphed by this picture here. Wow, that's kind of one of those questions that we don't like because it really is like, you know, 7 questions in one. But you know what? You got to do what you got to do. So here we go. Bailey bought a Bruin card, that's kind of a tongue twister, for $10. With the card, he can get in football games for $2. Matthew didn't buy the card. He pays $4 to get into football games. Excuse me. For what number of games does Matthew pay more than Bailey? So I think we can just kind of do a little chart here. Number of games. And then here I'll put, you know, M-A-T-T for Matthew and B-A-I-L for Bailey. Okay. So let's just say there were 1, 2, 3, 4, 5, 6, 7, 8. We'll stop at 8, see if we need to go higher. Let's do all of Matthew's costs. Matthew didn't buy the card, so he pays $4 for every game. So if he went to 1 game, that's $4. 2 games would be 8, 12, $16, 20, 24, 28, $32. Now Bailey is going to do a certain amount of money, $2 per game, but also the $10, right? So if we went to 1 game, he paid $10 plus 2, which is 12. So Bailey, if they only went to 1 game each, who would you rather be? We'd rather be Matthew. But what the question is asking for is, when does Matthew's game cost override or go over Bailey's? So 2 games for Matthew would be the $10 that he paid plus 4. 2 times 2, which is 14. So you'd still rather be Matthew, right? So next one, 10 plus 3 times 2 is 6, 16. Can you see the pattern now? 12, 14, 16, 18, 20, 22. Oh boy. So look, it's after 5 games that they ended up paying the same. But the question is, which would be 5 games, for what number of games does Matthew pay more? Is that at 5 games? No, because they're the same. And therefore the answer is 1 game further down. Matt pays more. I guess we could say at. That's okay. 6 games and above. Okay. Obviously after 6 it just gets worse for Matthew. So if you're going to go to a lot of football games, you'd want to do Bailey's plan. If you're just going to go to a couple, you want to do Matthew's plan. Boom! Math. Saving you some money. Okay. Number 9. Chelsea's Cupcakes offers $36 membership with cupcakes discounted at 3. Without a membership, cupcakes cost $4.50 each. What number of cupcakes does a member pay less money? Same question, y'all. Same question, right? So probably need a calculator handy for this, right? Okay, so this is the number of cupcakes. And right here we'll do $36 membership, so we'll do with a membership, and here we'll do without a membership. 1, 2, 3, 4, 5, 6, 7, 8. Let's do without a membership. 1 cupcake is going to cost $4.50. 2, on your calculator, multiply $4.50 times 2, you get 9. $13.50. Go to my calculator now. 18 is for 4 cupcakes plus 4.5 again, $22.50. Next, 27. Next, $31.50. Next, 36. Yikes, that's a lot of cupcakes. So I'm going to draw lines here to keep this stuff straight. So without a cupcake, we're up to $36. I mean, without a membership. Now with it, it's going to be, oh boy, $36. Oh man, that's going to be pretty high. It's obviously going to be none of these right here, right? Because, like, for example, 36 plus 3 is 39. Look how much more this person is paying for 1 cupcake compared to them. Then 36 plus 2 $3 cupcakes, which is $6, that's 42. And this is going to go up by 3s, so that's 45, 48, 51, 54, 57. You go, it's never going to catch up these. Well, that's just the nature of doing this without knowing the algebra a little quicker. One thing you can do is, obviously it's going to be a ways down. Why don't we just jump up to the number 15? and see if they've caught up. So this is going to be 36 plus $15 times $3 for each cupcake. 36 plus 15 times 3, which is $81. And over here it's $4.50 times 15 cupcakes, and you get 67.5. It's still cheaper. So this is like not fun, right? So what we could, yeah, I mean, there's a way to do this using algebra that can make life go a little bit quicker. Let's just do that. And that would be this. Notice the pattern here. This is $36 plus $15 per cupcake, and this over here is $4.50 per cupcake. So on the left is an expression for with a membership, and on the right is an expression for the cost without a membership. Oh, I'm sorry, this is 36 plus 3x. And so now we can just solve for x. And you guys are pros at that from chapter 1. Subtract 3x over 36 equals 1.5. That's what you'd get there, x. And now divide by 1.5, getting x by itself. Take out your handy dandy calculator. 36 divided by 1.5, 24. So I would have had to go for a long time. This is 24 cupcakes. Now 24 is where they're equal though. It asks for what number of cupcakes does a member pay less. So obviously it's one more. The answer is 25 cupcakes. You say that word enough, it sounds weird. Cupcake, cupcake, cupcake. You know, it's just, wow, what am I saying? It's weird. Okay, done. Thankfully. My goodness. Number 10. Greg started the school year with 32 service learning hours. Oh yeah. During the school year, he earns 8 hours a month. Darren started with 2 and earns 14 hours during the 14 hours a month during the school year. For what number of months will Darren have more service learning hours? So let's go ahead and write an expression, right, for Greg. And that would be started with 32 and then 8 per month. So that's G for Greg. Darren is 2 hours, started real low, and added 14 per month. And we want to know for what number of months will Darren have more service learning hours. So Darren, we want to be more. Now this might be along the lines of what your teachers want. On the previous two problems, you can't go to half a game. You can't get half a cupcake. But here, it's a possibility, I suppose, that you could have part of a month. So we're going to set up an inequality, making Darren higher than Greg, and then just solve for x. So I'm going to get the x's on the left. You get your choice, but that's my custom. And then get the constants, 32, on the right. So 8 minus 14 is negative 6x, is less than, here, negative 30. Dividing by negative 6, those cancel and I get x is greater than, oh, why, notice I switched it, right? We should be good at that now. Pros, over here is 5. So really, Darren will have more service learning hours if, at least this is, for what number of months? For months, number of months greater than 5 months. So literally at 5.1 months, presumably, you could do that. Darren is going to overtake Greg and be the big dog when it comes to service learning hours. Now your teacher might want you should really clarify with them. This is the review. Hopefully you're doing it before the test, obviously, and you should ask them, did you want more than 5 months, or did really maybe what they want is 6 months? Okay, all right, moving on. Marissa is trying to lose some weight. So far she has lost 13 pounds. Wow, that's extremely difficult. Very, very happy for her. Her goal is to lose 51 pounds. Okay, sounds like a medical issue. She is on a calorie counting plan that will allow her to lose 2 pounds a week. What's the minimum number of weeks she must follow her plan before she hits her goal? So really this should say her goal is to lose at least 51 pounds. If it was to lose exactly 51 pounds, we would use an equal sign. Okay? So let's go ahead and do the math, and that is she's lost 13, and now additionally she's going to lose 2 pounds per week. But we want that total amount to be bigger than 51 pounds. So this nice young lady's got a long way to go. Let's keep her in our thoughts, right? That's a long time. Subtract 13, subtract 13. Boom. 2x is greater than 51 minus 13, 38. Oh, divide by 2, excuse me. X is greater than 38 divided by 2 is 19. But what are we talking about? 19 weeks. So anything over 19 weeks, which, you know, your teacher, again, might be thinking 20. Now, explain your reasoning. Well, that's the thing is, I'm kind of lucky because when I do this, I get to say my reasoning, don't I? But you, as a student who's going to pass a piece of paper to your teacher and say, here, tell me what I've learned, you have to write it. And this is not the answer. Explain your reasoning. 'Cause. Okay? No. That won't work. Okay? So you need to, like, give a complete sentence. Okay? But in all honesty, I'm not exactly sure what your teacher's going to expect to see here. So I'm not sure. You should really just talk to your teacher about this one. So go ahead. You could come pick on me, stop by room 260 and say, Mr. Dees, you didn't know what to write. But I'm not sure what your teacher wants there. Explain your reasoning. So, but this right here is the total amount of pounds she's lost, and this is the total amount that she wants to lose, and so we have to set that greater than the goal, okay? Or else you don't meet your goal, right? All right, good. Moving on. Number 12. So for problems 8 through 10, well, we already did 8 through 10, didn't we? Yes. So this is probably 12, well, through 16. Right? All right. Things change. So let's go ahead and solve for y. I would subtract 12, piece of cake. That's going to say 3x minus 12 because those are not like terms is greater than 4y. Now dividing by 4 everywhere. Boom, we're done. It's just that customarily we write the variable we're solving for on the left, although technically you don't have to. So if I write y on the left, it's pointing at y, and then I have 3x minus 12 over 4. That's an acceptable answer. Some of your teachers might take this and separate it and write the 3x over 4, which cannot be reduced, minus 12 over 4 is 3. So you can write this there or this there, and you're correct. Number 13, solving for y again, I would subtract 4. So this is virtually the same, right? This is 7x minus 4 is less than negative 9. Y. Dividing by negative 9 everywhere, these cancel. I get y. The alligator's eating y, isn't it? Oh my goodness. Woo! I caught it. I caught it. So you can't clown. I divided by a negative, so I got to reverse the direction of that. And now that's 7x minus 4 over negative 9. I'm going to rewrite it. Y, the arrow or the inequality is pointing at y, so I point it at y. 7x minus 4 over negative 9. Great. That's 12 and 13. Now 14 introduces something called absolute value. And you know what, guys, there's just a lot of ways to talk about this. On the first one, I'll give you some behind the scenes, you know, like, hey, here's how to think about it, and then at some point you want to become an algebra monster and just do them correct, you know. Both are good. So here we go. If I covered this up and I said, what number could be under here so that it's true? Those of you that know what absolute value is know that it could be a 10, right? Because what's the absolute value of 10? It's 10, and that's greater than 5. What if I put a 6 under there? Sure. The absolute value of 6 is 6, and that's greater than or equal to 5. How about 5? 5 works, because the absolute value of 5 is 5, and 5 is greater than or equal to 5. How about 4? No. The absolute value of 4 is 4, and 4 is not greater than or equal to 5. So far, 10 worked, 6 worked, 5 worked, and then 4 didn't. And as I keep going down, try negative 4. Negative 4, if negative 4 was under here, what's the absolute value of that? 4. Is 4 greater than or equal to 5? No. So you see what's happening here is as I go down, there's going to be a gap between lower than 5 and bigger than negative 5 that don't work. And what that means is that whatever's under my finger can be... There's somebody knocking at the door. I need to go get that real quick. I don't, but I'm like, I'm actually, no, I'm like, this is actually recording right now. Can you hang out for just 1 second? Yeah. All right. Hey, a former student here came to visit, and so let me finish this up, and then I'm going to visit with her. Okay, so what I was saying is, whatever's under my finger here has to be bigger than or equal to 5, or less than or equal to negative 5. So let me go ahead and write that. Y minus 3 is greater than or equal to 5, or y minus 3 is less than or equal to negative 5. So let's go ahead and solve for y on both. I'm going to add 3. That's gone. And I get y is greater than or equal to 8. Or, and then over here, if I add 3, it's y is less than or equal to negative 2. So great. And then it says graph the solution. So my two important numbers are negative 2 and 8. I am greater than or equal to, so that's a solid dot, 8. And I'm less than, or I'm less than or equal to negative 2, so that's solid. And go like that. And there's the answer. And I'm going to stop this and pick it up in a second. So continuing on with number 15, solve and graph the solution if possible, which by the way indicates a neat thing that sometimes these really aren't possible. So let's just go see what happens here. You want to get first the absolute value by itself. Remember the last one we did? It was already by itself, but now it's not. So let's get that by itself. We'll pretend like that was just a variable or something like that. So first I would add 5 over, and now these would be gone, and I'd have 27 is less than 3, absolute value of r plus 2. And now, to get the absolute value by itself, I would divide by 3 on both sides. So the absolute value of r plus 2 is greater than, over here, 9. And now we're very much like we were right here. But now you'll notice, oh yeah, and still the absolute value is greater than. And here's just kind of a shortcut. Some teachers hate using shortcuts. I understand they have their purpose. But I already explained why I'm about to do what I'm going to do. When it's greater than, when the absolute value is greater than, you need to set what's in the absolute value greater than the number, or set the absolute value less than the negative of the number. Okay, that's what we did here. I set it equal to Alright, I said it made it greater than or equal to 5 and less than equal to negative 5. And so I'm doing the same thing right here. And now as I get r by itself, r is greater than over here 7, or right here subtracting, r is less than negative 11. So this is the solution where I've solved it. And now when we graph it, negative 11 is smaller, so it's on the left. 7 is bigger, so it's on the right. These are open circles, and I'm shading away, right? Greater than 7 is this way. Less than 11, negative 11 is that way. So these are the solution. This is the graph of the solution. Moving on, number 16. Now this one, it looks like m plus 1, the absolute value, is less than 21, but you can see as I solve first, I'm going to divide by negative 7, and I get m plus 1, and this switches directions, and we get negative 3. So just like before, when you divide or multiply by a negative, you are going to switch the sign. And so now we're right back at that place where I take what's in there and I write it down just like I see it, or I write it down less than or equal to its negation, which is positive 3. Continuing to solve, I subtract 1 everywhere, so m is greater than or equal to negative 4, or subtracting 1, m is less than or equal to 2. And now watch what happens here. This is pretty neat. Negative 4, 2, greater than or equal to negative 4. So if that's going to be a solid circle, and shaded which way? To the right. And if I do m is less than 2, that's a solid circle, and shaded to the left. And so look, what's actually shaded? Well, everything is shaded. And so the answer is all real numbers. That's actually what we would state for the answer now, and there's the picture of it. Okay. Now why is that the case? I'll just spend a minute talking about that. Here it says the absolute value of something is greater than a negative. Now when is that true? Well, it's always true, right? The absolute value is either 0 or more, but it's never negative. And so no matter what number I plug in right there for m, it's always going to be greater than or equal to or greater than negative 3. And so there you go, all real numbers. Okay, best wishes, get some rest. Maybe your teacher will let you bring a granola bar, but main thing is study, study, study. Watch this again if you think it helps. Okay, good luck.